Hello class, in today's video we're going to be going over number sequences and introduction to arithmetic sequences. The learning intention of today's video is we're going to develop an understanding of sequences and patterns. We're going to be looking at different examples of number sequences. We're going to learn how to label terms within a number sequence. We're going to understand what is an arithmetic sequence. And lastly, we're going to learn how to determine the value of any number within an arithmetic sequence recursively. So the first part of today's lesson is understanding what is a sequence. So a sequence is a set of items, and an items could either be a number, it could be a letter or a symbol that follows a particular pattern or a rule. A pattern is what we refer to as a written description to explain how each successive term is obtained, meaning that the terms are next to each other, right next to each other. How does that relate to one another, and how does one increase or decrease from the other? So in these examples over here, I've got two sequences over here, and each of these two sequences have their own unique patterns. And we can actually determine or predict what these patterns are, so that we can actually predict the next value or the next item in the sequence. So in the first example, I've got a sequence that contains numbers. So this is a number sequence, and in the example below, I've got a picture. So just trying to show you guys that sequences doesn't necessarily have to be numbers, but in most cases we're going to be handling with number sequences. Now my third dot point says each item which makes up a sequence is referred to as the word as term. So in this case over here, each of these individual letters or individual numbers or symbols are referred to as a term in this case over here. So it's really important that you do understand the differences between the terminologies. Now, I've got a really fun activity for you guys to do right now. So what I'd like you to do is spend 5 to 10 minutes working on this. So draw this particular table over here. And what you're going to be trying to do is trying to identify some of the patterns that are present in these examples over here. So they can have quite interesting patterns. So I want you to predict the next two terms, meaning the next two numbers in the actual sequence, but also come up with a rule or a pattern to describe how do you get the next number within a sequence. So please pause this video right now so you can have an attempt at this, and then afterwards please compare your answers with mine. So for the first one over here, notice that in this case over here, it keeps on increasing by the same rate in this case. So that's going to be my rule. My rule is going to be, it's going to be increasing by +2. So that's going to be my rule. And therefore, because I know it's increasing by 2 each time, the next two digits are going to therefore be 10 and 12 in this case over here. Now, if I'm going to go down the column, 13, 8, 3, and -2. In this case over here, it's going down by the same amount. It's going down by -5 each time. So the rule is you're going to be subtracting 5 from the previous number, and therefore the next two digits are going to be -7 and -12. In the third example, in this case over here, what we're doing is we're actually multiplying it by -3. So from 3 to 9, you're multiplying by -3. From -3 to 27, you're also multiplying it by -3, and so forth. So that is the rule over here. And if you did this, then the next two digits are going to be 243 and -729. 29, sorry. Now, for the other ones over here, this is going to be a bit more tricky. So in this case over here, the rule is that you're actually dividing the number by 3 each time. Because if I was to write this as a fraction, 9, or just write it as a whole number, 9 divided by 3 gives me 3, 3 divided by 3 gives me 1, 1 divided by 3 is essentially writing like 1/3 as a fraction. And if you did this again, then the other fraction is going to be 1/9, because 1/3 divided by 3 is 1/9, and 1/9 divided by 3 gives you 1/27. The next few numbers in the other sequence over here, in this example over here, if you recognize these numbers, these are perfect square numbers. So the rule is pretty much the consecutive squared numbers. So after 49, the next squared number is 64, and the next one is going to be 81. For the next one over here, what you're essentially doing, this one is you're dividing it by 2 each time. So that's the rule. So these are the next two digits. For the next one over here, this is a common sequence that you may already come across with. So in this one over here, the way that they obtain the next number is that they've just pretty much added these two numbers together to give you this number here. So that gives you 2. If you added these two numbers, that gives you 3. So the rule is you just add the previous two terms to get the next term. And in my last example over here, the rule is going to be that I just add by 4 to each previous number. So that was a pretty simple one. Now, if you couldn't identify some of the sequences or the patterns, don't stress, because the only ones that we really need to worry about are the ones that involve adding or subtracting by a constant amount. Don't worry too much about the dividing or multiplications or the squared numbers. Those are just some really interesting examples that I want you to see if you could actually determine it or not. So I've got an example over here. I've got -8, -3, 2, 7, 12. So that's our sequence over here. And instead of referring it to as the first term, for instance, which is -8, or the fourth term in this case, which is 7, there's a way that we could actually make it a bit more simple to just label it. So we're going to be using labels. And the way that we label it is by using the letter T. Now we use the letter T because each of these numbers are terms. So therefore we use a letter T to represent term, and we use a subscript, meaning the smaller number next to it, to indicate the position within the actual sequence in itself. So therefore the symbols T1, T2, T3, etc. are used as labels for the first, second, third terms within the sequence. So that's kind of self-explanatory over here. And we use the subscripts to indicate the position of each term in the sequence. A common mistake that students often think is that they think that the number 1 in this case represents, that's the value of the first number in the sequence, but that's not necessarily the case at all. So the number over here just means that what is the first position within the sequence. It's not what is the first value, because we can see that the first value is equal to negative. So please make this distinction over here. So if we were trying to actually label a term that wasn't really shown in the sequence at all, then we could actually use this same label system to actually refer to it. So for instance, if you want to find out or identify the 100th term, then you'd write T subscript 100. So this is just another example to show you how we could actually use these labels to indicate the position within the arithmetic within a sequence. So this over here is pretty much a general way of representing or labeling terms within a sequence. So we use the letter T, and then N represents a number which indicates the position within the actual sequence itself. But something that you want to know is that N can never be equal 0. So if you're trying to identify or label the first term, then it's going to be T1, not T0. So let's look at the example down below. So it reads, for the sequence 2, 8, 14, 20, 26, and 32, state the values of T1. So T1, remember, indicates the first value within the sequence. So T1 in this example over here is equal to 2. So therefore T4 in this case equals to 20, and T6 equals to 32. So this is just quite easy stuff, but it's really important that you understand what these, notations are. So what I'd like you to do for the next 10 minutes is I'd like you to please copy down the questions and answer them. These are relatively easy, I think, so it shouldn't take you more than 10 minutes. So please pause this video right now to attempt the questions, and after 10 minutes, then check your answers to see whether they're correct or not. If you've done this successfully, then these are the answers that you should be getting for these questions. We'll now be moving on to the next section of the video. So what we're going to be looking at now is a specific type of number sequence, which is referred to as an arithmetic sequence. So in each of these different examples over here, although they have different numbers or different terms within the sequence, all of them share one exact same similarity. So for instance, if I was to find the pattern in the first example or in all the other examples, notice that they kind of go up or down by the exact same amount. And because it's a fixed increment, meaning it goes up by the same amount between the next numbers every single time, we refer to these specific sequences as an arithmetic sequence. So all of these numbers in an arithmetic sequence have a constant, or we might refer to it as linear. So they have a constant linear difference for each consecutive, meaning the numbers next to each other. Now, an arithmetic sequence, also known as a linear sequence, is where the difference between one term and the next consecutive term, it's constant, meaning that it goes up or down by the same amount, and this amount is what we refer to as a common difference, and we express the common difference or label it by the letter D. So for instance, in our first example up here, we can clearly see that this increases by 1. In the second example, they go up by the same rate, so they go up by positive 3. Now, unlike the first two examples, the third example, this is where you're going down. This is still classified as an arithmetic sequence because it goes down by the same rate or the same amount. Now, we said that the common difference is pretty much what it increases or decreases by. So in my first example, my common difference is going to be positive 1. We know that the second one is going to be positive 3, and the common difference for the last one is going to be negative 5. So from this particular slide over here, I really want you to be familiar with what the word common difference is and what letter we actually use to represent the common difference, because this is going to make a lot more sense in our next lesson. What I'd like you to do right now is I'd like you to please copy down this particular table inside your exercise book, and with the 5 following sequences, I want you to identify whether that particular number sequence is considered to be arithmetic or not. In year 12, when you do this topic again, you're going to be looking at various types of sequences and its names as well. But the purposes of this curriculum, we're only going to be interested in arithmetic. So sequences that go up or down by the exact same amount to find out the next consecutive number. And if it is arithmetic, then I want you to find the common difference. If it's not arithmetic, then just leave that row blank in that case then. So please give yourself 5 minutes and then compare your answers with mine. If you guys have done this successfully, the first one is going to be arithmetic because there is a common difference of positive 2, so it keeps increasing by positive 2 each time. For the second one, this is also an example of an arithmetic because it goes down by 1.5 every single time. Our next example over here is not an example of an arithmetic sequence. As you can see over here, this goes down by 4, but for the next to get the next number, this actually went down by 6. So because they're not uniform, they're not constant, then there is no common difference in this case over here. In our next example, this is not an example of a common difference as well. So therefore, we're going to leave this blank. And for our last example, this is an example of an arithmetic sequence. Now notice in this case over here, they're kind of going up by positive 6 each time. So therefore, the common difference is 6 in this case. We're now going to be looking at the last part of today's lesson, which is finding values of the nth term in a sequence. Now, what do I mean by the nth term? It just means if I was trying to find the value of any term or any position within an arithmetic sequence, I represent that by the letter n in this case here. So although an arithmetic sequence generally gives us like the first few the values, it's possible to determine the value of all the other terms in an arithmetic sequence. So in my number sequence 3, 7, 11, 15, 19, I know that I've got the first 5 terms, but if I could actually work out, for instance, what is the value of the 6th term, I can find out what the value of the 20th term, or I can even find out the value of the 100th millionth term if I really wanted to. And to represent the position of any number within the sequence, I just use the letter n in this case over here. So that's what Tn means, sorry. And there are actually 2 ways that we could actually determine the value of any term within the sequence. The first way is by using the recursive formula, and that's what we're going to be looking at in today's lesson. But this method over here is a bit more tedious. It's a bit more longer to actually work it out. But there's also a shorter way to do it, and this is referred to as using the explicit formula. And we're going to be looking at this particular formula in our next video. So firstly, how do we actually represent the arithmetic sequences recursively? Now, recursive kind of just means repeating. So like a recurring number, recurring decimal, the number keeps on repeating itself. Using that same definition in this context over here, we can kind of do the same thing every single time to obtain the next value. So representing an arithmetic sequence recursively means to describe the relationship between each successive term. So look at the example down below just to have a better understanding, because if you read this description, you probably have no idea what I meant. So if, for instance, if I was trying to find what is the value of the 20th term in the sequence, what I need to do firstly is I need to identify what is the common difference and what is the first value. Because if I've got these two informations, I can find out the value of any number or any position within a sequence. I know that my first term in this case is going to equal to 5, and I know that in this particular example over here, it keeps on increasing by positive 5. So the common difference is by positive 5. When I have these two informations, I can find out anything. In an arithmetic sequence, we say that values can be determined by pretty much adding the common difference constantly. So in this case, if I was to find the second term, although I know it's equal to 10, to find the second term, all I do is if I have the first term, I just add it by the common difference. So therefore 5 plus 5 is equal to 10, and that can be shown over here. To find out T3 in this case, if I know what T2 is, I just add that by the common difference, so 10 plus 5, and I just keep on doing this. Now, if I was to try to find what T20 is, what that means is I need to pretty much keep on doing this repetitive, tedious, long step until I know what T90 is, T19, so that I can find what T20 is. So I keep following this same calculations until I find out what T19 is, and then I substitute that value into this formula over here to find out the value of T20. So as you can see, this is a very long method, and I haven't actually shown you the full working out, but I just wanted to show you how do we actually find something recursively. So you don't copy down the example of here for now. Copy down the example that I'm about to show you in the next slide. So in this particular example, this question is asking us, find the next three terms in the arithmetic sequence recursively. Now, it's pretty much what you've done in the earlier review questions, but we're going to be now using full working out to show this recursively. So because it's asking us to find the values of the next three terms, essentially what the question is asking us to find is find the values of T5, T6, and T7, since we know the T1, T2, T3, and T4 already. So in this case, to find out T5, all I need to do is firstly find out what T4 is, which in this case I know is 24, and then add it by the common difference. In this example over here, notice that this is increasing by the same amount. It's increasing by positive 7 each time. So if I added 27 to 24, the fifth value in the sequence is going to be equal to 31. To find out what my sixth value is, I just add the common difference to the fifth value. So therefore 31 plus 7 in this case is going to equal to 38. And do the same thing to find out what T7. So therefore this is going to equal to 45. This is how you would show full working out in order to get this mark if the question specifically asks you to show this recursively. Alright guys, what I'd like you to do right now is for the next 5 minutes, try to use the complete working out to show the next three terms for this particular arithmetic sequence recursively, and then check your answers with mine. Now, if you guys have done this successfully, this is the answers that you should have got. So I think this is fairly simple, so I'm not going to really be explaining this, but if you did need help, then please email me. Alright, there's another component of the recursive formula, and it's how do we actually write the general recursive formula for a particular arithmetic sequence. Now, the general formula to represent the arithmetic sequence recursively is shown on the right hand side. So it says to find out what Tn or T, whatever the term you want, you need to find what is the term beforehand. So that's what this Tn minus 1. So for instance, if I was to find out what T5 is, I need to know what T5 minus 1 plus D is, which is simplified as T5 plus T, oh sorry, that's a 1 over there, which is equal to 5 minus 1 is equal to 4. Oh boy, what am I doing? Plus D. So that's how I would write that recursively, and I also need to specifically state what the initial value is, because with by knowing what the initial value and by knowing the common difference, I can find out any value. So let's look at through some of these examples over here to see how do we actually represent this using the recursive formula. So the first step again is identify what is your first term. So my first term is going to be 3 in this instance. And then I need to find out what is the common difference. So how much does it go up or down by? In this case, it's going up by positive 7. So if I was to represent this recursively, I just substitute these values over here into the recursive sequence formula. So in this case over here, it would be Tn is equal to Tn minus 1 plus 7. So I just substitute where D is, D being 7, and T1 is equal to 3. So that's why I have 3. And that's it. That's our final answer. In the second example, again, just identify what is the first term and the common difference. First term is 11, and in this case, it's going down by 3. So I'm going to write -3, and it's important that you include the correct signs. Therefore, substitute the value of D and the T1 into this recursive formula. Therefore, your answer is going to be like this. Okay, guys, I've got the recursive formula, the general formula, so try to use that to answer the following 2 questions. Give yourself 3 minutes for this, and then compare your answers with mine. If you've done this successfully, this is what the answer should be for both of these questions. I'm hoping that you guys have done this successfully. So this is pretty much the end of today's lesson. But there's one thing I do want to note out, that now in different textbooks, or if you go on the internet and you kind of like just research or Googled up recursive formula for arithmetic sequences, they might use a different formula instead, but I can assure you they're the exact same thing. Now, instead of using the letter T, they actually use the letter A, and you're going to see this in your Google form exit ticket as well. The reason why they've used the letter A in this case is because it's arithmetic, so A just represents an arithmetic term, but you can use this interchangeably. It will just vary between countries and textbooks and stuff like that. So don't be too confused or alarmed when you see different letters. They mean the exact same thing. So in the next lesson, what we're going to be doing is we're going to be using the explicit formula to find out what is the terms within an arithmetic sequence. And I can assure you this is going to be a lot more efficient. So for now, you're going to have to suck it up and find the values of a arithmetic sequence in the long way, so by doing the repetitive stuff. The review questions I'd like you to do for the remainder of today's lesson is these questions over here. So there are 3 questions, 2 questions on this particular slide over here, and as well as this question. Once you've done that, then please attempt this exit ticket over here. There's about 8 multiple choice questions or so it shouldn't take you too long. This is the end of today's video. Hopefully this video helped you guys. Thank you for watching. I'll see you in the next video. Bye.